Parallel plate capacitor or parallel plate condenser. They are one and the same thing. As the word parallel plate means there are two plates which are parallel. So one plate is this and another is this plate is positively charged, this plate is negatively charged. The area of cross section of both the plates is A. They are of equal size and equal shape. The distance between these two plates is small d. There is a vacuum in between the plates. Now we will consider these plates as a infinitely charged sheet. For infinitely charged sheet, what we mean that the electrical field for the infinitely charged sheet will be equal to sigma divided by 2 epsilon 0, where sigma is charge density on the plate and epsilon 0 is the permittivity of the vacuum or air. So here there is a positive charge, here there is a negative charge. Here charge is Q1 plus Q minus Q. Here surface charge density sigma, here also sigma. The area of this plate is also A, area of this plate is also A. The distance between these two plates is small. Now, what will be the electrical field due to positive charge and negative charge? Due to positive charge plate, the electrical field is E1, its direction will be away from the positive plate. So, in between these two plates, it will be in this direction, and outside this plate, E1 will be in this direction. Because positive is here, it is away from it. So, direction of electrical field due to the positive charge plate is E1. Here its direction is upward, here its direction is downward. Now for the negative plate, the electrical field is E2. In between this, E2 will be toward the negative plate and E2 will be towards B plate in outside upper square and lower side also it will be. So electrical field here E1 and E2 are in opposite direction. Here also E1 and E2 are opposite direction. The value of E1 and E2 is same. E1 and E2 is sigma bata 2 epsilon 0. E2 is also sigma bata epsilon 0. So the magnitude of these two are same and the direction is opposite. And there will be no electrical field outside this plate, this side or outside. So there will be no electrical field. Electrical field will be 0 in this region or the region which is outside this plate. So here there is no electrical field. Here there is no electric field. So no energy or no charge will be there in this region, which is outside this region. So the electrical energy will not be here, which is outside the region. Now, what will be the electrical field in between the plate? In between the plate, the direction E1 is downward, E2 is also downward. So they are in the same direction. So the total electrical field in the region which is between the plates will be E1 plus E2, and so it will be equal to E1 plus E2 and it will be summit, then sigma bata 2 epsilon 0 plus sigma bata 2 epsilon 0 is equal to sigma bata epsilon 0. So electrical field in between plates is sigma bata epsilon 0 and electrical field outside is 0. So the electrical, when we charge the capacitor, the energy will be stored in the electrical field and which will be in between the plates, or the charge are stored at these plates. Positive charge here, negative charge here. So the charging of the capacitor we have learned that we will connect this to positive of battery, we will connect this to negative battery. And when their EMF of the battery is same as the potential difference between these two plates, then the charging will stop. And when it is charged, then what will happen? The electrical energy will be stored in this region, and this region is bound region. So the electrical field is bound here. Electric field outside is zero. So the energy is stored, that is will be also in the bound region. So as I have discussed earlier, for the spherical capacitor, the electrical field was distributed. It was not confined or it was not bounded. It was from charge split to infinity. So that energy cannot be utilized for producing a large current. So here this capacitor can be used to produce a large current, and which is required for the starting of motors, fans. Also when we discharge it, then it can be used for electrical flush. So the total electrical field inside this will be equal to total electric field is sigma bata epsilon 0. Here electrical field is 0. Here electrical field is 0. So what will be the potential? Difference between the potential difference will be equal to electrical field multiplied by the distance between the two plates. Electrical field is sigma bata epsilon 0 multiplied by T. So the potential V will be equal to E into D, that is sigma bata epsilon 0 into T. Now charge density, simplify the charge density. Charge density is charge per unit area. So the charge, total charge plus here, Q here, minus Q here. So the charge density will be equal to Q bata A. It doesn't depend upon the plus or minus. The charge density will be equal to Q bata A. It will depend only on the magnitude. So the charge density, sigma will be Q bata. So we substitute the value of charge density here. Then the potential will be equal to sigma, we can put Q bata A into D bata epsilon 0. So potential will be equal to Q into D bata A into epsilon 0. Now the capacitance of the capacitor will be equal to the ratio of charge divided by the potential. So C0, we write C0 because the medium between this plate is either air or vacuum. So C0 is equal to Q bata V will be equal to epsilon into A divided by T. So the capacitance of this parallel plate capacitor will be equal to epsilon 0 A bata T. So the capacitance will depend upon two factors. One is the area, so C is proportional to A. Second factor, C is proportional to 1 bata D, or C is inversely proportional. So for the large capacitance, the area should be very large and the distance between these two plates should be very small. If instead of air or vacuum, we have a dielectric constant, we put a dielectric here, then the electrical field will be reduced. The electrical field will be equal to, in this case, electrical field will be equal to E divided by E0 divided by epsilon R. Epsilon R is always greater than 1. So there will be a decreasement, or the electrical field will be reduced by placing the dielectric instead of air. So in the dielectrical medium, what will be capacitance Cm will be equal to epsilon A bata D. Here it was epsilon 0 for the vacuum or air, and epsilon is for the medium. The permittivity of this dielectric medium into A bata D, and this will be equal to epsilon 0 into epsilon R A bata D. So this will be equal to epsilon R into C0, which is E0A beta D. So we can say that by placing the dielectric, the electrical field will be reduced, potential will be reduced, therefore capacitance will increase, and the capacitance when the dielectric medium is always ER times the capacitance when air is there. So this is all about the capacitance, parallel plate capacitance. Now, parallel plate capacitor, as I told you earlier, parallel plate capacitor is charged by the battery, positive charge, when it is connected to positive of the battery and negative of the, and it will charge up to the point where the potential difference between these two plates is equal to the EMF of the battery. After that, there will be no charging or the potential will not increase, and maximum potential between these two plates will be always equal to the EMF of the battery. Now we have considered that the plates are of infinitely large charge sheet. Now how we can say that the charge sheet is infinite plate? Now if we consider, suppose you are standing near the board and you are seeing very close from the board, then you will see that the end of this board will touch to the sky. Therefore, the distance D, which is distance between the plates, should be very very small in comparison to A. And when D is very small, then only these two plates, which are actually plates, are behave like a infinitely charged sheet. And the electrical field, as I have told you earlier, the electrical field in between the plate is bounded. It is not distributed, bounded. So the energy stored can be used instantly for the production of high current. So now what type of the parallel plate capacitors are? Now parallel plate capacitors depend upon what factor? One factor is the area of cross section, then the distance between two, and then the dielectric between them. Now for the different dielectric, the parallel capacitor will have a different thing. The first dielectric we use a paper we can use a paper as a dielectric. Paper is an insulator, and if we plate a very thin film of aluminum whose thickness is 6 to 7 micrometer, and here we put a paper, then this type of condenser, parallel plate condenser, will be paper condenser. Then second we can use a plastic. Instead of paper, if we use a plastic. Now plastic is also a insulator, dielectric. The dielectric constant of plastic is more than that of the paper. So the capacitance in which the plastic is placed in between the plates will be more than paper. Then third we take the ceramic capacitor. In ceramic capacitor we plate some salt of ceramic. The dielectric constant of ceramic is much higher than paper and plastic. So the capacitance of ceramic capacitor will be higher or will be larger than plastic and paper. Moreover, the size of ceramic capacitor is much smaller than paper condenser and plastic condenser. Now third type of condenser is electrolyte condenser. Now for these two conductors plate, we can have any, suppose this is the capacitor, we can have this plate positive and this, we can also have this plate negative, and so there is no hard and fast rule that this plate should be connected to positive and this should be negative. So for this paper condenser, plastic and ceramic condensers, they plates can have any polarity. The size of ceramic condenser is very small. The 2 points are here and this is the ceramic. So here the size is very. So these capacitors are generally used in computers and many electronic instruments where we have to reduce the size. Then third type of condenser is electrolyte condenser. Electrolyte condensers are those conductors which has a definite polarity, plus or minus. We have to connect plus to the positive battery and negative to this. If we reverse it, then this capacitor will be destroyed. And electrolyte capacitors are used in power supply. In power supply, we use diode to convert AC into DC. Now the output of the DC is fluctuating. It is not constant. And actual DC is the magnitude of voltage should not change. So to make the pulsating DC to pure DC, we can use the capacitor to have pure DC from the pulsating DC. And next type of the capacitor is AC condenser. As I have told you earlier that AC capacitors are used in fans, in motors. Why the AC conductors are used? AC capacitors are used in motors and fans. If you see, you will see a capacitor is like this. It is aluminum cylindrical and having two terminals. Then one terminal is light and another is earth. So in AC we have the 2 points. One is the light and another is this. So we have to connect light this point and earth to this point. Because in AC there is no positive and negative. But for this condenser we have to use negative earth to the earth point and light to the light point. And last is variable condenser. Variable condenser are those condensers whose capacitance can be varied. Now these capacitance are used in radio. Because we know that frequency is equal to 1/2 pi under root LC. Now you can vary the C. Then frequency will be changed. When the frequency of your radio and frequency of radio station match, then there will be resonance and you will hear the program of that. So value of L cannot be changed. We can change the value of C by the variable capacitor and we can get the desired frequency and we can receive the radio signal in our radio or transistor. So this is all about the parallel plate condenser. Now if the parallel plate condenser is there and we have a partially filled, not completely filled, we are partially filled. So this is the positive plate, this is the negative plate, and here we have a dielectric and its thickness is small d. The distance between these two is small d. then only the thickness of dielectric is small t. Now how the capacitance will vary? By putting the dielectric whose thickness is small t, its area of cross section is same as that of the plates. So we can verify it. Now for the air, if it is not there, if the dielectric is not there, then for electrical field was equal to sigma bata epsilon 0 as we that earlier, and sigma is equal to q bata a. Then so the electrical field E0 in the air will be equal to q bata a epsilon 0. In the dielectrical, electrical field will be equal to E0 bata epsilon, or we can say sigma bata epsilon. Instead of epsilon naught, we will have the epsilon. Epsilon naught is permittivity of the vacuum or air, and epsilon is permittivity of the dielectric medium. We substitute the value, then we will get this is equal to q bata a epsilon 0 r, or this is equal to E0 bata epsilon 0. As I told you earlier, so ER, the value of ER is more than 1. So the value of electrical field will be reduced by inserting a dielectric plate. Now we will find what is the capacitance. So now since the thickness of the dielectric tube, now the area, the width of air will be equal to d minus t. So the potential due to air will be equal to, you multiply E0 by the distance between these two plates, that is equal to d minus t air. So the potential will be equal to q bata a epsilon 0 d minus t. Here it was d, because here there was only air. So now instead of d, we will add d minus t, because the air will have only the space, that is d minus t. Now for this medium, the potential will be equal to the electrical field multiplied by thickness. The electrical field is En multiplied T, that is equal to q bata a epsilon 0 into epsilon 0 into T. So the total potential will be sum of these two. Total potential of sum of these two will be equal to D will be equal to q bata a epsilon 0, the constant, and T minus T. This factor is for the air and this factor is for dielectric T bata 2. So we can find the capacitance. Capacitance is equal to q bata V. So we cross multiply, then q bata V will be equal to a epsilon 0 divided by this. So the capacitance will be equal to q bata V will be equal to a epsilon 0 divided by d minus t minus common area minus t bata. Now if t is equal to 0, then it will be all total will be air, then it will C will be equal to same as here epsilon 0 a bata t. If you put t equal to 0 here, if we place instead of dielectric, if we place the metal, this is very important question, mostly asked in the examination. If we place a metal whose thickness is T. Now since the dielectric constant of metal is infinite, so ER will be infinite. So what will be the C will be equal to Q bata V, which will equal to A epsilon 0 1 minus T bata 1 bata infinite. So this will be equal to 0. So the capacitance will be equal to A epsilon 0 D minus T. So this is all about the parallel plate condenser, where only one dielectric plate whose thickness T is equal. Now, if the by the insertion of the dielectric constant will increase. Why it will increase? Because it is D minus T plus A. So T minus T bata epsilon R is more than 1. So this vector will be always minus. So the capacitance will be higher when we put the dielectric instead of we are having only the air. Now we have to find the capacitance if the parallel plate capacitor is completely filled by the dielectric. It means the distance between these two plates is completely filled by the dielectric. There is no air. Now we take the charge of this plate is positive, charge of this plate is negative. The distance between these two plates is small d. The electrical field, as I told you earlier, electrical field here will be equal to 0, electric field outside will be equal to 0, as we have discussed for the parallel plate condenser. So only the electrical field will be inside it. It will be due to positive plate this side, negative polar. So electrical field will exist only between the plate or in the dielectric, and electrical field will be 0 outside the plate. So the electrical field, when the dielectric there, the electrical field will be equal to sigma bata epsilon 0. Now sigma bata epsilon 0, epsilon, because sigma bata epsilon twice epsilon positive का गया, and sigma bata twice epsilon minus plate का. Since both are in the same direction, so total electrical field will be equal to sigma bata 2 epsilon plus sigma bata 2 epsilon, that is equal to sigma bata epsilon 0. So this will be the electrical field in between the plates or in the dielectric. So we can put the value of sigma. Sigma is equal to charge divided by area. Epsilon 0, epsilon is equal to epsilon 0 into epsilon r. So this will be equal to, the electrical field will be equal to Q bata A epsilon 0 into epsilon. Now what will be potential? Potential will be the electrical field multiplied by the distance between the plate. So potential B will be equal to E into D. E is your QD. We multiply by D, so Q into D divided by A into epsilon 0 epsilon r. So now what will be the capacitor? Capacitor is equal to Q bata B. We divide B this side, it will go upside. So A epsilon 0 ER bata D. So this will be equal to same as A epsilon 0 D multiplied by epsilon r. Now this is capacitance of this condenser. Instead of dielectric there is air, so we can say it is CO multiplied by ER. So ER is greater than 1. Therefore ER is greater than E0. So the capacitance when the dielectric medium will be greater than when the medium between plate is air. Now we take the second case of the parallel plate condenser, when large number of plates of different thickness and of different dielectric constant are placed in between. So this is the positive plate and this is the negative plate. The electrical field here will be equal to 0. As I told earlier, electrical field here will be equal to 0. Electrical field will be exist only in between the plates. So here they are, suppose D is the distance between these two plates. And suppose there is a dielectric whose thickness is T1 and dielectric constant TR1, then T2, TR2, T3, TR. There are many plates and their thicknesses are T1, T2 there. So, what will be the air? Air will be equal to T minus sum of this thickness of plate. So, the air will be D minus, air will be D minus T1 minus T2 Tn. So this is the space available for the. So distance for air will be this one. T1 is the dielectric. T1 is the thickness of this, and dielectric constant is ER1. Here ER2 and so on. So T1 thickness, T2 thickness, dielectric constant T3 and so on. There are n plates. Then what will be the total electrical we can find? So the air will be, as I told you, the air will be D minus T1 minus T2 and available this. So what will be the potential due to the electrical, due to the air only, then we have to put a V0, that will be equal to E0 electrical field due to the air or vacuum multiplied by the distance available for the air, that is equal to D minus T1 minus T2 and so on. Now for the dielectric constant, what will be the electrical field? Electrical field will be equal to E0 divided by the dielectric constant of this, and potential will be equal to the electrical field multiplied the thickness. So the potential for the first, whose thickness is T1 and dielectric constant ER1, then potential will be equal to E0 divided by ER1 into T1, and the density will be equal to Q by epsilon. So you will put the value of density here, and electric equal to E0, then we can find V will be equal to Q by A epsilon 0 into epsilon R multiplied by thickness. So total V will be equal to V0 plus total VI. We put it VI. VI is equal to E0 bata epsilon R1 into T1. So we can put the value here. E0 is equal to Q bata A epsilon 0. So the V will be equal to this V0 for the air plus Vi for the different slabs of dielectric. So we can write this will be equal to Q bata A epsilon 0. This is E, and distance for the air is D minus T1, T2, and so on, plus for the dielectric Q bata 4 pi epsilon 0 summation of Ti bata Tri. So we expand it, and the capacitance will be equal to Q bata V. We can divide it and we can put it, then we can find the capacitance will be equal to Q bata V will be equal to A epsilon 0 D minus T1, T2, T3 and so on, plus T1 bata epsilon R1 plus T2 bata epsilon R2, T3 bata epsilon R3 and so on. So we can get the total capacitance when n dipole is there. Now we can say if we can consider the case when there is no air. Means D is equal to T1 plus T2. This term will be not there because there is no air. So it will be equal to A epsilon 0 divided by T1 bata epsilon R1 plus T2 bata epsilon R2 and so on. So this will be the capacitance. And if we are suppose L plate and their thickness are equal, then T1 will be equal to T2 is equal to that will be equal to all equal. So it will be equal to A epsilon 0 D minus NT plus T common आ जाएगा 1 बटा epsilon R1 plus 1 बटा epsilon R2 and so on. So we can find the capacitance in the case when large number of dielectric slabs are placed in between the parallel plate. Now we will take another example of capacitor, that is spherical capacitor. Now what do you mean by spherical capacitor? In spherical capacitor there are two plates as in the case of the parallel plate, but here the plates are spherical in the shape. The inner is V shape. It may be spherical shape or it may be square. It makes no difference. So if it is a V sphere whose radius is R1, and outside it there is a spherical cell whose radius is R2. Now we connect the V, the inner sphere, with a wire and which is passed through a insulated area here and connected to positive. So the positive charge will be here on the V and it will be equally distributed on the surface of conductor P, and let this charge is Q. Now due to induction there will be a negative charge induced in the inner surface of A and outer surface will be positive and outer positive surface will make it earth. So there will be only negative charge inside the spherical cell whose radius is R2 or A. Now what will be the potential? We have to find the potential at due to A and due to B. Now if we consider that in between these two, this is sphere and this is spherical, there is a dielectric medium and we take a dielectric medium whose dielectric constant is K. It is filled here. So in between the A and B there is a completely filled with the dielectric medium. So the charge on B will be positive here. It will be negative here this side. Now at the P, what will be the potential? Now we can find the potential at P as we have derived earlier. The potential on the surface of a conductor which is spherical will be equal to V will be equal to 1 bata 4 pi epsilon 0 into K, because medium is dielectric, into Q bata R1. R1 is its radius. Now the electrical potential at the point B due to the outer spherical cell A whose charge is negative, that due to this negative charge on A, the potential at the surface of B will be equal to 1 bata 4 pi epsilon 0 K minus Q bata R1. So suppose we take this V1 and V2. So total potential will be equal to sum of these two. The total potential on V will be equal to V1 plus V2. V1 plus V2. We substitute the value. V1 1 bata 4 pi epsilon 0 K into Q bata R1 minus 1 bata 4 pi epsilon 0 K Q bata R2. So if we take 1 बटा 4 पाई एप्सिलॉन 0 q बटा k कांस्टेंट, देन इट इज इक्वल टू 1 बटा r1 माइनस 1 बटा r2. So we take LCM, then 1 bata 4 pi epsilon 0 k, and at the numerator there is a capital Q, R2 minus R1 bata R1 R2. So this will be the total potential on B sphere due to its own potential and due to the charge on the A spherical cell. So this will be the total potential, and we can call this is the potential of B. So we write VB, which is equal to V1 plus V2. This will be equal to 1 bata 4 pi epsilon 0 Q bata K R2 minus R1 bata R1 R2. Now what will be the potential at A? Now the potential at A surface spherical cell will be 0 because it is connected to 1. So the potential will be 0. So the potential of the spherical cell A will be 0. So the potential difference between B and A, VB minus VA, will be equal to VB minus 0 because VA is 0. So the potential difference VB minus VA is equal to 0. So we can call it V. The potential on V will be equal to 1 bata 4 pi epsilon 0 Q bata K R2 minus R1 bata R1 R2. So by this way we can find the capacitance of the capacitor. The capacitance of the spherical capacitor will be equal to Q bata V. So the capacitance in which the medium is there, so I write Cm will be equal to Q bata V, and this will be equal to 4 pi epsilon 0 K R2 into R1 bata R2 minus R1. So this will be capacitance of a spherical condenser whose inner radius is R1 and outer radius is R2. Now the capacitance will depend upon how many factors. Number one factor, the capacitance will be maximum if K is more. The dielectric constant is more, then it will be more. And if instead of dielectric constant, if there is air, then K will be equal to 1. Second thing, R1, it is R2 minus R1 bata. So the value of R1 and R2 should be large. The value of R1 and R2 should, because it is the numerator, so they are in product. So R1 and R2 should be large, and the difference between R2 minus R, it should be small. So this will be the condition when the capacitance of a spherical cell will be more. Number one, when K is more, means instead of air we put a dielectric constant, because the dielectric constant of any dielectric is more than 1, or that is the more than dielectric constant of the air. Second thing, R1 and R2, they should be large, and in denominator then R2 minus N, but the difference between R2 minus R, it should be less. So if we are having a, instead of dielectric we have a air, then C air will be equal to, you put it here, and you put K is equal to 1. So this will be the capacitance of a spherical condenser in which air is in between these. Now if I2 is very small, I2 is very large, or we can say the R1 is equal to R1 is equal to R, and R2 is equal to infinite. Then we can put it, the C will be equal to 4 pi epsilon 0 R K into R, divide कर दें इसको, तो the 1 minus R bata R2. Now R2 is infinite, so this will be equal to 0. So it will be equal to क्या होगा? This will be equal to 4 pi epsilon 0 K into R. And if K is equal to 1, then it is equal to 4 pi epsilon 0 into R. This is the same capacitance of a spherical condenser which we have derived earlier. So in this way we can say the spherical capacitance is also used and its capacitance is large and then parallel plate capacitor. It will depend upon the radius of inner and outer and the dielectric placement.